Alrighty, this is 8-1 for algebra, example number 1. Lots of different parts here, so buckle up. You're in for a ride. Yeah, I don't know. All right, so consider the following sequence. And remember that a sequence is just a list of numbers. That's all that really is. So a sub n, remember that subscript right up there, is 1, 7, 13, 19. So a list of numbers, right? Shocking. Okay, so as per the green bubble, does it say anything about an a sub 0, or does it give us an a sub 0? The answer to that is no, it doesn't. It doesn't say anything. It doesn't give us anything. It just starts. So that means that we get to make the assumption that this first one right here is a sub 1. Now, notice the way we're going to label this. I would absolutely recommend that you start doing this on yours, which means this is a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, and so on and so forth. Because remember that n, that input, is the term's placement in the list. So when we're looking at a sub 3, that's the third term in the list, which happens to be that 13. So when number 1a here asks us to find function notation here, this is function notation, they're asking me to find a of 5, which is the fifth term. The fifth term would be 25. So a of 5 is 25. Now, they could have asked you that same thing by asking you a sub 5. You know, those two things are the same exact thing, just again, a different way to write them. Function notation versus the subscript notation. That's what's going on here. We have your subscript notation, or sorry, your sequence notation. Sequence note. So this is asking me to take a sub 2 and add it to a sub 6. Easy enough. A sub 2 is 7 plus a sub 6 is 31, would give us 38. All right, so jumping back to function notation here, they want me to take a of 4, which is 19, and they want me to add that. Okay, and notice what's going on here. We got a little crazy stuff going on here. We have a 2 in front of the a of 6. Now notice I did not, that's still not multiplication. That's not a times 4 or a times 6. That's a of 6. So whatever a of 6 is, which happens to be 31, I need to take that and I need to multiply it by 2. So 31 times 2 plus 19 gives us 81. Okay. Part D, asking us to find the square root of a sub 5. A sub 5 is 25, so the square root of 25 is 5. Has nothing to do with the fact that it's the fifth term. You know, those two pieces being 5s are not related to each other. That's a coincidence. All right, so now in E, a little bit different here. There's Jesus, I can't even speak English. They are saying a sub n is equal to 13, and then there's a question mark. So what are they asking me exactly? Well, they're asking you what the n is. They're asking you 13 would be a sub what? They're asking you to find n. 13 is the third term like we talked about before, so n would be equal to 3. Or you could write a sub 3 equals 13. Either one. Okay, next up we are noticing a pattern. Do we see anything that is common between, going from one term to the next? This unit is going to be all about noticing patterns. Pattern, yay! Yeah. All right, well, going from 1 to 7, if I'm going from 1 to 7, the only way I can get there is by adding 6 or multiplying by 7. But multiplying by 7 immediately isn't going to work because 7 times 7 isn't going to give me 13. But 7 plus 6 will give me 13. 13 plus 6 is going to give me 19, and I can see that this pattern is working out for me. So what is the pattern? I'm adding 6 each time. So adding 6 each time. That just looks like a, there we go. So then, is there a CROC? What does CROC stand for? Hopefully we know that's constant rate of change. Is there a constant rate of change? Is there something that I'm adding or subtracting by? And there is. It's that 6. Yes. There's a constant rate of change of plus 6. Another fancy name for constant rate of change would be a slope. More recently, and at the end of our last unit, we talked about a new fancy word that we're going to get into a lot next lesson of common difference. Okay, so last but not least, we just need to write an equation to represent this. Well, if there is a constant rate of change or if there is a slope, the equations that have slopes are our linear equations. Linear because of the constant rate of change. So a linear equation is that y equals mx plus b. Two pieces that we need filled in would be that slope, that m, and the b value, which is the y-intercept. So we know here that we've actually already got our slope, that pattern, that thing that I'm going up or over the same amount each time, that plus 6. Okay, so insofar, I could do y equals, yes, computer, I know, I'm trying, 6x, and then we just have to find b. In theory, you might think that it would make sense for 1 to be my b value, but unfortunately, it's not. Because if we think about real quick, sidebar, if we think about a y-intercept, a point on the y-axis, intersecting with the y-axis, has coordinates of 0, comma, whatever that y value is. We know that the x value has to be 0. And the problem with using a sub 1 as the y-intercept is that it has an x value or an n value or an input of 1, not 0. Therefore, that means, very, very important piece here, that a sub 0 is the y-intercept. So whenever you're making an equation, you can't use a sub 1, you have to use a sub 0. Well, I don't have a sub 0. Okay, but we know the pattern, right? If I start with a sub 1, I need to add 6 to get to the next one. We already determined that. We already figured that out. So then if I have a sub 2 and I want to go backwards and didn't know a sub 1, I would do the opposite of adding 6 and subtract 6. So therefore, I can use that same process to go backwards from a sub 0. 1 going backwards, 1 minus 6 would get me that a sub 0 of negative 5. I feel like I wrote that in a really bad spot. I'm going to have to fix that at some point. So a sub 0 is equal to that negative 5. And what did we do? We worked backwards. I'm just going to reiterate that. We had 1, comma 7. So we added 6, but then we went backwards and subtracted 6 to get that negative 5. So then y equals 6x minus 5. But like we said, we're not using x and y anymore. We want to be using a and n. So a of n, my function notation, is equal to 6n minus 5. And again, I'm just going to label that with function notation. We're going to get in the habit on your practice problems. I ask you to write it in both function and sequence notation. So this is just what that's going to look like. Sequence notation being that A sub n, and then literally the rest stays the same. Just the A sub piece is different. So woof, that was a lot, but that's the bulk of it.